The results to flood in, I asked Andy Norton about a project he's involved in. Andy, tell me about WASP.
Yes, at the Open University we're part of a project called Super WASP, the Wide Angle Search for Planets. It's a set of cameras that have just started working in La Palma, and what we're doing is essentially surveying the whole sky, looking for planets around other stars.
Hang on a sec, there's a lot of stars in the sky.
There are an awful lot of stars, yeah.
It's going to take a long time if you take a picture of each one.
Well, we've got a very wide field of view, so we can sample a lot of stars at one time, tens of thousands of stars in a single image.
But you can't see a planet, they're all dark and small.
Well, just as Venus is going across the sun today, what we're looking for is planets around other stars that pass in front of those stars. And when the planet passes in front of the star, it will dim the light of that star by just a tiny amount.
But only 1% or less.
Less than 1%, and that's what we can measure. That's what we're looking for.
You can't see 1%.
Well, yes, we can. We can monitor these tens and hundreds of thousands of stars, looking for just these tiny dips as the planets pass in front of them. And if we see that repeat in a periodic way, that's a planet going around a distant star.
That's fantastic.
It really is.
So how many do you look at in each picture?
About 10,000, 20,000 in a single picture, and we can take pictures across the whole sky through the night.
How often? Of each place?
Okay, we can visit each place maybe every few minutes or every half hour, something like that, and we can build up our record of each of the individual stars over many minutes, hours, nights, night to night, week to week, month to month.
Fantastic. And then is there anything you can tell about the planets if you find them?
Well, yes, there is. Once they've been confirmed, and we'd need other observations to confirm what we've found, but once we've confirmed them, because these planets pass in front of the star, when they do, just like with Venus, some of the star's light passes through the atmosphere of the planet, and as it does so, some of the light is absorbed by the atoms and molecules in the planet's atmosphere, and by looking at the signature of that absorption, we can tell what's in the planet's atmosphere.
Wow, and whether there might even be life
and
there.
that might give us a clue to whether there's life on the planet.
That's fantastic. Thanks, Andy, and good luck with finding planets. And good luck to everyone who tried to time that third contact. Here's Lucy with some results.
Now, let's have a look to see what our Stardate average distance is. So this is the compilation of everybody all over the UK who's contacted the website and entered in their times. So, Michael, let's have a look. I can see that it's coming out to be 160 million kilometres. So that's our Stardate average. That's looking very good. But actually, today, when we measure the distance to the sun, we use radar techniques, and they tell us that the sun is about 150 million kilometres away. So the results coming in are a little bit too long, but I think that's probably because it's very hard to get the precise time of when third contact occurs. So people are a little bit hesitant to make that recording, and that's delayed.
Now, from my observatory in Chelsea, and we're all here waiting for the start of the transit of Venus. There's a whole party of us, all feeling very excited. Conditions are perfect, and I think we're going to have a good view. And we're about to see something that no one now living has ever seen. So let's hope the skies stay clear.
One of the things that's changed most since the last transit was observed in 1882 is the sheer variety of equipment we've got to look at it. And we've got good examples here today. This is a typical modern telescope with the filter film over the front and over the finder, so it'll be perfectly safe. And we'll line that up using the shadows just to tell when you're looking at the sun. This is a hydrogen alpha telescope, picks out a particular level of the sun's surface, and we'll be using that to look for prominences of solar activity later on. This, Patrick's first telescope, still works, of course, and we can use it just to project the image of the sun onto this piece of paper, and we'll easily be able to watch Venus moving across the sun's disk later on. So all we have to do now is hope the skies stay clear and wait for a good transit.
What is a transit of Venus? Well, there are two planets, Mercury and Venus, which are closer to the sun than we are, and therefore sometimes pass between the Earth and the sun and appear as black disks against the sun's face. Mercury transits quite often, Venus doesn't. The last transit of Venus was in 1882. The next will be in 2012, not seen from here, and then no more until the next century. So this is something very special. So far as we're concerned, it is a one-off.
Okay, Bob, so we're 6 o'clock, we're just 10 minutes, 15 minutes away from the start of the transit, and you've probably got the most high-tech way of viewing it here. What are you looking at?
I'm looking at the sun in a very tight frequency band. I'm looking at hydrogen alpha. What I'm actually doing is I'm seeing the hydrogen on the sun, and I can see the top half of the photosphere.
Right, so you're further out than the visible surface.
A little bit more, not very much, just a little bit. But there's one or two really, really nice prominences
right, because
on
you're
it.
picking out the active areas
Sure.
on the sun.
Yeah.
And we looked yesterday and there was absolutely nothing.
But it's fantastic today. It couldn't have been better. I mean, I can't believe this. There's a massive prominence on the side. it's sticking right out, and I'm just really hoping that what we'll do is, as Venus comes into the top part of the photosphere, I'll begin to see it.
Yeah.
There's a bit of a bet on between everyone how early I get it.
That's right. This is the first time, of course, we've seen the transit of Venus in hydrogen alpha. This technology wasn't around 123 years ago.
I don't actually know whether we can see it in hydrogen alpha.
And does it have the black drop effect in hydrogen alpha? What do you think?
I don't know.
So something else we won't have seen at the last transit was here with Jamie Cooper sitting with a laptop. So what are you hoping to use the computer for during the transit?
Basically very simple. We've got a webcam, or a modified webcam. It takes a short movie, so you get those little seconds where there's very steady seeing. We take those frames out of the movie and create an image.
Fabulous. So Damien, we're now probably 5 minutes away from the start of the transit. How's it feel?
I think it's very exciting. Everyone here is excited and really looking forward to, for it to start.
What's the view like through your telescope?
Yes,
Found the sun?
Yes, it's looking quite good at the moment. We've only got like 15 minutes to go now, so...
If that.
Yes,
so
not long.
And you're working in just normal visible light?
That's right,
yeah.
Now we know the transit is about to start.
Yeah, I've got it in H alpha. It's there. It's right on the very limb. I can see it just cutting through the top of the photosphere.
Can't see it on the projection yet. I can see it just coming in on the edge of the disk now. There's a very small bite.
There it is. There's Venus now. Just first contact, a tiny notch. Venus now passing onto the disk of the sun for the first time since 1882.
And it's like the world's smallest eclipse. Just a cut, first contact.
And when we come to second contact, which will be in, I think, in about 10 minutes.
Yeah, it's moving rather quickly.
Then we'll see possibly see the backdrop.
That's right. So Damien, it's really clear now on the projection. We can see Venus is half onto the disk. What's the computer showing you?
Yes, it's showing Venus about halfway onto the solar disk now. Yes, it's looking very clear. About 4 or 5 minutes time we should see the black drop.
Now, how's the contrast? Because one of the things about Venus is it's incredibly dark, much darker than any sunspot.
Yes, it really just looks like a small bite has been taken out of the edge of the sun at the moment.
That's right. You certainly couldn't confuse it, and it's much larger than any sunspot.
Oh, absolutely,
group,
yes.
It's incredibly obvious. Venus now seems to be almost completely on the disk. What's it look like with the naked eye?
I can see it quite clearly, and there's no mistaking it now.
And even after 47 years of the sky night, it's something we've never seen before, and like nothing we've seen before.
And we won't see again from here, after all. This really is a one-off, and I'm so glad we have these perfect conditions.
Exactly. It's nice to have a blue sky for something
astronomical.
Really is. I think that's second contact.
No, it's not yet.
No, not yet. There's still a faint sliver there.
It's nice to have the high-resolution people behind us. So
exactly.
They can keep me right. It just illustrates how difficult this would be.
Well, you have my first telescope.
And it's about the same size as Horrocks telescope, of course.
Very close.
We like to think we're the authentic ones in the garden, and this is the modern approach behind us.
This is what I had when I was 11 years old.
Did you think then you'd be seeing the transit of Venus with it?
No. And there is the black drop. No question about it. It's quite unmistakable. If we tried to time the moment for second contact, we couldn't have done it. So the black drop really exists in the visual light anyway.
It doesn't happen in H alpha.
You don't have a black drop in H alpha?
I've just got a straight disc.
That's something that no one said before. There's no black drop in H alpha.
Well, I can't see a black drop.
Anyone else see one? So second contact's now okay. I think the black drop's gone, Patrick, if you have a look.
It has?
Yeah,
I did.
So I think but we saw it clearly with the projection through the telescope, the old-fashioned way of looking at things. But the people using webcams, using modern cameras, didn't see a black drop, which is the first time, as far as I know, anyone's seen the transit of Venus without seeing that. Have optics improved? Have cameras improved?
I wonder. We used to think the black drop was due to Venus's atmosphere. We now know it's not. The Venus does have an atmosphere, a very curious atmosphere, and Venus indeed is a very curious kind of world. A little while ago, I talked to Professor Fred Taylor.
One of the things that worries us about Venus, apart from trying to understand the very high temperatures and pressures on the surface, is the dynamics of the atmosphere. We think we understand the dynamics of terrestrial planet atmospheres, particularly the Earth. We use this knowledge for weather forecasting and so on. When we try to transfer that to Venus, it all goes wrong. Because Venus has tremendously high winds around the equator. They're actually stronger than hurricane force, more than 200 miles an hour, blowing constantly around the equator in this very dense atmosphere. It's absolutely remarkable, and we don't know what's driving that. We'd really like to get more data on the meteorology of the atmosphere and try to understand this strange behavior. At the poles, Venus has an enormous vortex, thousands of miles across, which turns out to be double. Instead of a single eye in the middle with air descending, which is what we expected, it's actually double, and there are two vortices going around the pole, and the same thing at the other pole. This again is behavior that doesn't correspond to our understanding of terrestrial planet atmospheres.
And of course Venus has a very slow rotation, 243 Earth days, longer than a Venus year, but the upper clouds go around in 4 days.
Yes, that's what's so remarkable. It's 60 times the speed of the surface underneath.
And also, in a sense, opposite to that of the Earth. That goes back to front.
Yes, everything goes back to front, that's right. That's something that's telling us something about the very early history of Venus that, again, we don't understand. One of the things that we would also like to get much more about is an understanding of volcanoes on Venus, because with the Magellan data, we can see these enormous volcanoes on the surface. We can see runs of lava that are hundreds of miles long. So Venus is obviously a very volcanic place. But what we don't know is how to date that volcanism. Is it an ancient effect that we're seeing remnants of, or is it happening now? And I think that the bizarre state of the atmosphere is telling us that it's probably happening now, but we don't know for sure.
What about the changing amount of sulfur dioxide in the atmosphere?
Yes, that too. The Pioneer Venus spacecraft observed for 10 years, and during that time, the amount of SO2 in the upper atmosphere changed by a factor of 10.
That's indicative.
And that sounds like volcanoes erupting and then slowing down a bit and presumably erupting again. What we need to do is look at the behavior of those gases in the lower atmosphere, which we've never seen before, which we'll get from the Venus Express mission that's coming out next year.
I remember the time when Venus was called the planet of mystery. Well, we found out a lot, but there's still a large number of problems remaining.
There certainly are, and I think it gets more mysterious the more we learn. You know, there have been nearly 30 spacecraft missions to Venus, and there have been telescopic observations since the discovery of the Ashen Light in 1643. We still we've acquired a massive amount of data, but we still don't really understand how the planet's behaving. And as I said, that's actually quite worrying, because it is the most Earth-like planet.
I think one thing is quite definite. There can be no life on Venus as we know it, and probably never has been.
No, I think that must be right. It is possible, perhaps, to imagine ecological niches in the clouds and so on, but I think that's rather far-fetched.
I remember giving a talk in London, one about 1960, and I said then that as a prospective colony, Venus might be more promising than Mars. How wrong I was.
Yes, indeed, but it really did look that way.
It
should have been better than it is. I wish we understood why.
So Ninian, we're at 7 o'clock, we're almost an hour into the transit, and you're observing in H alpha.
That's right.
So could you explain what that is for us?
A hydrogen alpha filter shows